Alright guys, this is your warm-up. You need to get out your unit circles and try to find these two values. Okay, please push pause for about 3 minutes and let them find these values, please. Alright, just making sure everyone understands what this is. This is a radian, okay, which is about where 80 degrees is, way over here, okay. This point is -1, 0. Remember, tangent is y over x, so that would mean that your x value is -1, your y value is 0, so this actually equals 0. Okay, at pi over 2, you are up here at 90 degrees. Okay, and this actual value is 0, 1, which means that you have 1 over 0, which is undefined. Okay, very, very important that you can find these values for today because we're going to be graphing tangent. Alright. Okay, just kind of a rehash of what we did yesterday. Okay. We graphed cosine. Alright. And remember, cosine actually makes a wave. Okay. I made you guys do a T-chart or actually graph, like, write out the points. So it looks just like this. Remember, you find these points on the unit circle. Okay, don't forget that you're going to need to find domain, range, amplitude, and the period for each one of these. Okay, amplitude is the distance from the midline to the top of your graph. Okay, the period is the distance according to the x-axis from when the graph starts to repeat itself. And you can kind of see that it makes two copies right here. 1, 2, just like this. So from 0 to 2 pi is 1 copy. So the distance is 2 pi. Okay? We also did sine. It should look like this. Just kind of check over your graphs from yesterday and make sure that yours is right. Okay? Again, same 4 things. Alright, make sure your T-chart or points are right, okay? And make sure your graph is actually the right way, okay? Alright. We also did secant, which looks like this. Remember, with secant, you can actually draw cosine and just flip it over if you need to. Okay, I do expect to see these asymptotes here. Alright, remember the asymptotes happen whenever you have undefines. Okay, domain and range are a little bit more complicated on these two. Remember, x cannot equal the asymptotes. Okay. Make sure that you either put comma, etc. or comma, ... right here just to kind of show that it keeps going and it repeats itself. The range is from -infinity to -1. This is or, okay, that's the symbol for or. And then 1 to infinity. I do not mind if you actually write or out, okay? Amplitude, this is not a wave, so it's NA. And then the period is 2 pi. So that's what we did yesterday. So today we're actually going to be graphing the other 3. Alright. And the first one we are going to do is cosecant. Alright. There we go. This thing is kind of in the way. Alright. First thing we need to do is actually plot the points. Remember, cosecant is the reciprocal or the flip of sine. Okay? So whenever you're doing this, the x values are not going to change. They're going to be the same. So it's going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay? Because those are our angle measurements. The x-axis is always your angles. Y's are your values. Okay? So at 0 radians, you're looking at your unit circle to find these. At 0 radians, your y value is 0. So if you flip 0, okay, remember 0's fraction is 0 over 1. If you flip this over, you actually get 1 over 0, which is undefined. Okay? Pi over 2, so I'm straight up on the unit circle, and the y value is 1 there. If you flip 1 over, you get 1. Okay? At pi, again, you're at 0, so if you flip that over, you get undefined again. 3 pi over 2, you're down at the bottom of your unit circle, so that is -1. So if you flip a -1, you still get -1. At 2 pi, well, I'm back at the beginning, so it's undefined. Okay? So the first thing you want to do is just go through here and make your asymptotes. Remember, they are dotted lines going straight up and down. Just like that. Okay, and then we can plot our other points. So pi over 2, I'm at 1. So there's 1. Okay. At 3 pi over 2, I'm at -1. So I need a -1 over here. Just like that. Okay. Now, I know all of these asymptotes are going to keep doing the same thing. You kind of see that it skips a point, right? So it's going to skip a point, asymptote, skip a point, asymptote, right there. Right? Now, sine kind of looks like this. You kind of look back at your sheet, okay? And cosecant is the flip of sine. So if you notice that this right here is kind of going down from the point, and this right here is going down from the point. So it's going to be going up when we flip it. Okay? And this one right here is going to be going down, just like that. Remember, these lines follow the asymptotes. You can kind of see that they are alternating, so it's going to alternate going the other way. Just like that. And they're always going to be kind of curving down. Wow, that one's bad. And just like that. And that is cosecant. Okay. Now, domain. Domain is always going to be x cannot equal, and then whatever your asymptotes are. Now, don't forget your asymptote on 0. So it's going to be x cannot equal 0, comma. Now, if you notice, I have a positive pi and a negative pi, so it's just going to be plus minus pi, comma. Same thing with 2 pi and negative 2 pi, so plus minus 2 pi, comma. And then you can just put dot, 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 or etc. Either one, and we're good. Range is just like secant. If you notice that it's going down forever, and then it kind of comes up to -1, so it's going to be negative infinity to -1. Or 1 to infinity. And remember, the reason why we have to do 2 is because there's a big gap right here in our graph. Okay. Amplitude. Amplitudes only apply whenever there is a wave, right? And this is not a wave. Okay, it's like a whole bunch of parabolas, right? So this is in A. Okay, the period. Remember, the period is the distance where they kind of start to repeat itself. I have one up, one down, right? There's one up, one down. So they kind of repeat right there. So what is this distance? 0 to 2 pi, which is 2 pi. Okay, and I'm going to leave this here just for a second. Make sure you guys have everything written down. Remember, I'm perfectly okay with you guys actually drawing a dotted sine graph on this, just so you can kind of have a nice little guide on which way your lines go. Okay? All right. Tangent is our next one. Same kind of deal. Draw your x and y axis, t-chart, and then we're going to do our radians here. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay. Remember, tangent is y over x. So all the values over here, we're going to be pulling off the unit circle by using y over x. Okay? So, unit circle kind of thing. This point right here is 1, 0. This point is 0, 1. This point is negative 1, 0. And this point right here is 0, negative 1. Okay? These are our 4 points that we're going to be looking at for this right here for right now. Alright? So what we need to do is actually graph these. Plot them. So the y is our values. And over here it's 0. Y over x, so that's 0. Okay? Y over x. Well, I have a 0 in the denominator, so that means this is undefined. So that means we have asymptotes again. Y over x. Okay, so that's 0. Y over x. 0 is in the denominator, so that's undefined. And then y over x. Back to 0. Alright, so let's plot these points and draw our asymptotes. So at pi over 2, I have an asymptote. At 3 pi over 2, I have an asymptote. Okay, which means that it's skipping 1 again, right? So skip 1, asymptote. Skip 1, asymptote. Just like that. Okay, let's plot our points. 0, 0. Okay, pi 0, just like that. And then 2 pi 0, just like that. Well, I know that I'm going to have some kind of lines on this graph, and they're going to be following these asymptotes, right, in some direction. Well, at the moment, I don't really have enough information to actually know which way my line's going to go, because it's just right on the axis, right? There's no other point here to help me out. Okay, so we have to actually do a little bit more for a tangent, which is going to be the 45s. So we just kind of need a midpoint to kind of see where we're going. Okay, so you're going to have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Alright, let's kind of separate those a little bit. Okay, now at pi over 4, which is right here, okay, your point's going to be square root of 2 over 2 and square root of 2 over 2. Alright? Remember, tangent is y over x, so anything divided by itself is 1. Okay? In this quadrant over here, it's going to be the exact same points except for the x value is negative. So they're both over each other again, so it's going to be 1, but I just have a negative there, so it's going to be negative 1. Okay. In the third quadrant, I have both negatives, and 2 negatives make a positive, so that's positive 1. And then over here, I have 1 negative again, so that's negative 1. So all I need to do is come over here and write in my new points. just like that. I have a 1 and a negative 1 there. Okay. At pi over 4, I'm at positive 1. 3 pi over 4, I'm at negative 1, so down here. At 5 pi over 4, I'm at positive 1. And at 7 pi over 4, I'm at negative 1, just like that. Okay. Now if you kind of look at it, from this point, I know I'm going up to follow this asymptote right here. So it's going to be kind of like going up like that. From this middle, I see this point is down here, so I know this side is kind of going at a downward kind of angle, and then this one is going up like this. And this one right here is kind of going down. Okay? I know it's going to keep repeating this little pattern right here, so I know I'm going to have a point down here, and then a point up here, just like that, and it's just going to kind of keep repeating itself. Just like that. Alright, and that's what tangent looks like. Oh, my paper's a little off. Okay, so that's what tangent looks like. Just kind of a couple things, just kind of notice this graph right here kind of resembles y equals x to the third. There's just a lot of them, okay, as we kind of go through. Okay, domain is going to be done kind of like secant. So it's going to be x cannot equal your asymptotes again. So pi over 2 and negative pi over 2. So I'm just going to go plus minus pi over 2. Okay. Plus minus 3 pi over 2, comma, dot, 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 because it keeps going. The range, well look, it's going down forever and up forever. So that's all real numbers. The amplitude, this is not a wave, so it's NA. Okay. And the period, where does it actually start repeating itself? Let's see. From here to here, right? Well, kind of think about this. This is, pi over 2 is up here on your circle. 3 pi over 2 is down here, right? So that's half of a circle. So what's the radian for half of a circle? Pi. Okay, so the period actually is pi for tangent. So it's a little bit different than the other graphs. Okay, let me kind of straighten this up so everyone can just kind of make sure that you have everything. Okay. Cotangent. Well, for cotangent, I already know that I'm going to need all of these 45s because all of these values are just technically flipped, right? And I already know that I'm going to need these. So, whenever we make our t-chart here, I'm just going to kind of plug them in. That way we don't have to go back and forth. Okay, so this is going to be 0, pi over 4, pi over 2, 3 pi over 4, pi. I'm going to run out of room. 5 pi over 4, 3 pi over 2. Just extend my page. How's that? Okay. And then we're going to have 7 pi over 4 and 2 pi. Alright. And what we're going to be doing is we are technically just flipping all of these y values, right? So everywhere there's a 0, if I flip a 0, it's undefined. And everywhere there's an undefined, if I flip it over, it's going to be 0. All of the 1s, if I flip those over, they're going to just stay the same. Okay? So, flipping a 0, so it's undefined. Flipping 1, so it's 1. Flipping undefined, so it's 0. Flipping a -1, so it's -1. Flipping 0, so it's undefined. Flipping a 1, so it's 1. Flipping an undefined, so it's 0. Okay, flipping a -1, so it's -1. And then flipping a 0, so it's undefined. Okay, so there's your points. And again, the first thing you want to do is just come through here and draw your asymptotes, just like this. Again, it's just skipping 1, right? Just like that. And then I'm going to come through and fill in my 45 degrees. Okay? Now I'm only focusing on the positive side, really, okay? Just letting everyone know that. Okay, I know I have a point right there. Okay, at pi over 4, I'm at positive 1. Positive 1, sorry. Okay? So that means I need a 1 here, point here. At 3 pi over 4, I'm at -1, so I'm down here at -1. Okay, at 5 pi over 4, I'm at positive 1. At 7 pi over 4, I'm at -1. So you guys can kind of, those are much better curves than tangent. So it kind of looks like that. Now, they're just going to kind of repeat themselves on the other side, okay, for the negatives. So I'm going to have a point here, and a point here, a point here, and a point here, right? So it's just like that. Okay, domain. Again, x cannot equal my asymptote, so 0. Now I don't need a plus and minus with 0. Okay, plus and minus pi, comma, plus and minus 2 pi, comma, dot, dot, dot. Range again, down forever, up forever, so that's all real numbers. Amplitude, NA, not a wave. Period, you can really see that it's just pi on this one because it goes from 0 to pi. Alright, what I want you to do for the rest of the class is you should have another page that looks just like your notes, and I want you to fill out all 6 graphs with the 4 items, all of the t-charts, and turn it in whenever you are done. Finished or not, I am giving you a grade based on what you can actually get done. I will see you guys tomorrow.